Alright, so today we are going to be looking at transformations of absolute value functions. Transformations are probably something you saw in Algebra 1. We'll do lots of transformations of different types of graphs in Algebra 2. The first one being the absolute value function. So we have y equals the absolute value of x. That's our very most basic parent function. And what we're going to be doing is transforming that function. Here's what the transformations may look like. So there are a few different possible transformations. This is just kind of the general form. Okay, so our graph may have one or all of these transformations. A would be the number out in front of the absolute value, and this could do a few things. If A is negative, then we have a reflection over the x-axis. If there's any value there for A other than 1, it is a vertical stretch or shrink. Okay, and the stretch is if A is greater than 1. The shrink is if A is between 0 and 1. So that was A. B here is going to move your graph either left or right. So it moves left if we have a positive B, and it moves right if we have a negative B. C is very similar, except it moves your graph up and down. So C would move the graph up if it's a positive, and down for a negative. Alright, so let's look at a very basic transformation. Alright, so the first thing we want to do always is to list what our transformation is. Alright, so here we have this plus 1 after the absolute value, so that's going to move my parent function up 1. Alright, so I always start with a very basic table. Alright, and the basic table is for the parent function. The x values I'm always going to use, and these will always work for absolute value, is negative 1, 0, and 1. So what I want to do now is take the absolute value of all of those. So the absolute value of negative 1 is 1, absolute value of 0 is 0, absolute value of 1 is 1. So this is going to be the graph of the parent function then if we plot those points. So we've seen the parent absolute value function before. Here it is again. Okay, now our transformation is to move the graph up 1. So what I'm going to do is I'm going to go to those 3 points that we made and move all of them up 1 unit. Okay, so this red graph is my transform graph. Alright, so the red is g of x. Let's look at another example here. Alright, so this time we have a number out in front of the absolute value. That is going to give us a vertical stretch by a factor of 3, because 3 is the number out in front. Alright, so when we use when we have a vertical stretch, our table's going to look a little different. So we're going to have our x, we have absolute value of x for our parent function, and then we're going to have that third column of the table do our stretch for us. So it still starts the same way, negative 1, 0, and 1. I'm going to take the absolute value of everything from the first column, so still 1, 0, and 1. And now to move from the second to the third column, I'm moving from absolute value of x to 3 times absolute value of x. So I'm going to multiply everything by 3. Alright, so that would give me 1 times 3 is 3, 0 times 3 is 0, 1 times 3 is 3. So now the points I want to plot, here's my x-coordinate and here's my y-coordinate of the first point. Alright, my second point, my x-coordinate and my y-coordinate. Third point, x-coordinate, y-coordinate. Alright, so the table does the stretch part for us. That middle column is just to get us to that reflection over the x-axis. Okay. So a reflection we are also going to take care of in the third column of our table. So we have x, absolute value of x, and then our third column for this one is negative absolute value of x. So I start with my same x values of negative 1, 0, and 1. For my second column, I take the absolute value. And then to get from my second to my third column, I'm going to be multiplying by a negative 1. So everything in the second column gets multiplied by negative 1. And that gives us negative 1, 0, and 1. All right, so the first point that I'm plotting, here's my x, here's my y. So negative 1, negative 1. Second point, x and y. Third point, x and y. And we will go ahead and draw our absolute value function here. So notice that reflection just kind of flips it upside down. All right, next we have a minus 4 inside the absolute value. So if you look back up at the transformations, when it's inside the absolute value, it's going to move it left or right. And since we have a minus 4, that's going to move our graph right 4. Okay, so we still start the same way with our table. Since there's no vertical stretch or reflection, we just need the 2-column table. All right, so I have my x values. Take the absolute value of all of those and plot those points. Okay, so those are the points I'm going to be transforming. I know my whole graph is moving right 4. So for f of x, I'm going to take all 3 of those points and move them right 4. So that would put us over here. So notice the shape doesn't really change. Just my function is moving right 4 units. All right, so the blue graph is f of x. So it's our parent function moved right 4 units. So on the back here, we have a few problems that have multiple transformations instead of just one each. So first thing we want to do is list all of our transformations. So the negative out in front tells me that there is a reflection over the x-axis. The minus 1 inside the absolute value tells me I'm moving right 1. And the plus 2 on the end tells me my graph is going up 2. All right, the domain and range part, we'll wait until we get a graph here. So since I have a stretch, I'm going to need a 3-column table. And that third column is going to be negative absolute value of x. Remember, that third column only does the reflection or the stretch part. It doesn't move it left or right at all. All right, so my x values of negative 1, 0, 1. I take the absolute value for the second column. And then in the third column, everything is going to get multiplied by negative 1. So we would have negative 1, 0, and negative 1. So let's plot those points. Okay, so I'm not done yet. I've done the reflecting part, but I still have to move right 1 and up 2. So I'm going to take all 3 of those points and move them right 1 and up 2. So the green dots here give me h of x with all the transformations. All right, now for the domain and range. So for domain, I have to think about what my x values are doing. So notice this green function here is going to go left forever and right forever. So my domain goes from negative infinity to positive infinity. For my range, I have to think about what my y values are doing. So since both ends of my absolute value are going down, they're pointing down, it's going to go down forever. So I would start at negative infinity. But this graph only goes up to a y value of 2. If you notice on the graph, there are no y values above 2. So my y values range from negative infinity to 2. And we would include 2 there. All right, let's do one more that kind of encompasses everything here. So first we start by listing our transformations. All right, so first thing, that 4 is going to give us a vertical stretch by 4. The 1 inside the absolute value is going to move us left 1. And the -3 at the end there is going to move our whole graph down 3. Okay, so domain and range will weigh down until we get our graph to look at. So since I have a stretch, my table is going to need 3 columns. So x, absolute value of x, and 4, absolute value of x. So my x values are -1, 0, 1. My second column, I'm taking the absolute value of the first column. And now to get from my second to my third column, I need to multiply everything by 4. So I would end up with 4, 0, 4. So we would plot those points then, my parent points. So I would be at -1, 4, 0, 0, and 1, 4. All right, so now I still have to do the transformation where I move left 1 and down 3. So I'm going to go to all 3 of those points and go left 1 and down 3. And so those red points give me my new function, my transformed function. So when I think about domain and range, all right, my x values, those arrows are pointing left and right, and they're going forever in those directions. So my domain is -infinity to +infinity. My range, my y values start right here at -2. And since my absolute value is pointing up, they're going up forever. So my range is from 2 to infinity. And I would want to include that 2, -2, excuse me.